So we're still in 1.7, but now we're going to look at the algebra of functions. And the algebra of functions, it it includes the sum, the difference, the product, and the quotient. So we are adding two functions together, subtracting two functions, multiplying two functions, and taking the quotient of two functions. So you'll see this notation. F plus g of x is the same as f of x plus g of x. F minus g of x is the same as f of x minus g of x. Whatever follows here, the second letter is what you're subtracting. Fg of x means to take and multiply the two functions together. And then the last one, f divided by g of x, you take the bottom letter and that's what you're dividing by, f of x divided by g of x. So you're going to do this and it will give you a new function. The domain are the set of all real numbers that are in common to the domains of f and g. So you see this little upside down U, this means the intersection. So where the domains overlapped, they overlap are the domains of the function. So here, when we look at this one, we have, and you'll have to add this to your sheet of notes, letter A and letter C were, when it printed, it did not print on there. So f plus g of x, that is the same as taking f of x and adding g of x. Well, f of x is x minus 5. So that's what I'm going to put in place of here. And g of x, well, that is x squared minus 1. So that's what I'm going to put in place of here. So let's do that. So it's going to be x minus 5. And then I'm going to add g of x, which is x squared minus 1. I would combine any like terms here. Do I have any like terms? Well, like terms, let's remind ourselves what are like terms. Like terms have the same variable and the same exponent on that variable. If you have both of those, if you have the same variable with the same exponent, then you can, if you have both, you can combine the coefficients that they have in front. So here we have x and here we have x squared. So the same variable, but not the same exponent. There's an exponent of 1 here, even though it's not written. So we can't combine that. So I wouldn't combine x squared. I would just say x squared plus x. And why do I write x squared in front? I mean, you don't have to. I'm just writing it in descending order. But I do have two numbers here. I have my, -5 and -1, which will combine. And I will end up with minus 6. -5 plus a -1 will be -6. So this would be my answer here. Now, in order to find the domain of f plus g of x, remember it's the intersection. The domain of f intersect the domain of g. So what is the domain of function f? So the domain here, well, there is no denominator with an x in it, and there is no x under a even root radical. So the domain would be all real numbers. And then for function g, the domain there, also no x in the denominator, no x under a even root radical. So all real numbers. So then the domain of both of them, I mean, sorry, not both of them, but adding them would be just all real numbers. So if I want the domain of f plus g of x, it would be where they overlap, and they overlap everywhere, so all real numbers. Now, I also want to do the question over here, and it says to find the domain, or I'm sorry, first find f minus g. And so f minus g would be the same as f of x minus g of x. So again, here's g of x, and here's f of x. This one's a little different though because we have this minus sign. So we have to subtract everything in g of x. So when I put this in, I will put my parentheses there to remind me that I have to subtract everything that is in g of x, x squared minus 1. So that negative sign that you see in front will get distributed to both of these. And so I'll have x minus 5 minus x squared plus 1. So subtracting g of x changes the sign on the x squared, makes it negative, and it makes this plus 1. And now combining like terms, again, I don't have anything to combine with the x or the x squared, but these two numbers will add together. Negative 5 plus 1 will be negative 4. And so this would be f of x minus g of x. The domain here is, again, where they overlap, and they overlap everywhere. So the domain of f, oh, I put plus there, f minus g of x will be all real numbers also. So that is one way to combine functions. Another way to combine function is called the composition. And so this is not f times g. Don't think of this circle as times. Think of it as, it looks like the word fog. This circle here means composite. This tells you it's a composite function. So when we read this, it should be f composite g of x. And so it means that you're taking g of x and you're inputting it as the input into f. The domain of composite function, f composite g, is the set of all x such that x is in the domain of g, so it has to be in the domain of function g, or this is the inside function, and that g of x is in the domain of f. So all the things in g that the domain of g has, well, then you want to check it, is it in the domain of f? So here we have another example, and this time it's saying to find f composite g of x. So I'm going to write this. First, this is what f composite g of x means. And so we'll see here, we have this g of x. So I'm going to replace g of x with this. So I'm going to say this will be equal to f, and then in place of g of x, I'm going to put in 2x squared minus x minus 1. So this comes my input into function f. So then I'm going to take function f. Function f is 5 times whatever the input is plus 6. So I put blank spots in there, just like we did before when we were evaluating. So, but inside those blank spots, what is my input now? Well, it's function g. And so I'm putting an expression in here. So I'm going to first distribute the 5. And let's see, I get 10x squared minus 5x minus 5 plus 6. Do I have any like terms? Well, yeah, I have the numbers, but that's it. So these two will combine. And so to write f composite g, it would be 10x squared minus 5x plus 1. Is there, in this domain here, is there anything to exclude? both of them, g of x, because we're looking for the domain of g of x first. If x is not in the domain of g, then it must not be in the domain of f composite g. So here, for the domain of g of x, it would be all real numbers. And then we want to look for any x which is not in g of x, is not in the domain of f, must not be in the domain of the composite. And then we'll also look in the composite function, and we'll see this also, no x in the denominator, no x in the square root, and no x under a square root or even root. So then the domain here of f composite g would be all real numbers. So let's move on to this, and let's say the following values must be excluded from the input x. First, if x is not in the domain of g, because remember g is that inner function, whatever the inner function is. So they're just using g here for in general, because that's how we wrote it up here, f of g of x. It must not be in the domain of the composite function. Any x for which g of x is not in the domain of f must not be in the domain of the composite function. So that are talking about the values that must be excluded. So let's look at an example. So first we're going to find the composite function, and then we'll find the domain. So I'm going to write this, f composite g of x, same as this. And then let me highlight my g of x is here. So what I replace that with my g of x. So I'm going to say f of 1 over x. And so f of 1 over x, f of x is 4 over blank, the input. So we'll put a blank there, plus 2. And I'm going to input my g of x. And so I end up with this. So I get 4 over 1 over x plus 2. Now this is a complex fraction. The reason why it's called a complex fraction is because you have a fraction within a fraction. And in order to simplify this complex fraction, you have to, what you're going to do is multiply everything by all terms by the least common denominator. We have one denominator here, it's x. So if I multiply everything, so all terms is what I mean, by x, then what it's going to do is simplify that fraction. And I'll end up with 4x over 1 plus 2x. And this now is that complex fraction simplified. This is f composite g of x. And then if you scroll to the next page, it says find the domain. So we have to think about what is in the domain of g. So for g of x, it's going to be all real numbers, except what makes this denominator 0. So if I set the denominator equal to 0, that's what makes the denominator 0. So that means that I'm going to have from negative infinity to 0, and then 0 to infinity. And then I have to look at what works into the composite function, and we're going to continue that in the next video.